So in this case, we are going to continue with our displacement vectors. As per calculation, we managed to work out different, all right, vectors that we can be given from a Cartesian plane as we had before. Remember our displacement vectors. You were given a presentation where you are to obtain the vector from. But in this case, we want to determine or to calculate these displacement vectors from position vectors. All right, remember from the introduction that we had, a position vector is the one that is being taken from the origin. All right, it is taken from the origin. So let's say we have got a Cartesian plane in this case, all right? Then from the origin, a point is taken. Let's say this is the point P, which is taken from the origin like this. So that's OP is the position vector. So what is exactly the properties of that position vector from the point P? In this case, we want to consider given the coordinates of the point P. Remember the coordinate that x, y like this. That's a point in coordinate form. So given the point P, all right, let's say here it is corresponding to the x value, which is 3, and it is corresponding to the y value, which is 4, and therefore this point P is referred to as 3, 4, x value first, then the y value in this case. Thus, a point P that we are given. So if the point P is given as 3, 4, like this, that's a point that you are referring to. The position vector now, which is taken from the origin, which is a vector OP from the origin, is simply represented from that point. You simply represent that in column form. You take the point XY, represent it as a column. So that's in vector form. All right. So the 3 and the 4 like this. That's your vector OP. This is the idea of a position, what? A position vector. Taken from the origin. This is from the origin. So we can be given different points. Let's say there's another point here, all right, which is taken again from the origin, and this point is referred to as Q. And we are given the coordinates of that point. Let's say it is 4 minus 5 like that. The position vector of OQ, now that OQ from the origin is simply that point Q in what? Vector form, like this as a column. That's the presentation that we simply have. All right, so in this presentation, we are to determine or to find the displacement vector this time from these position vectors. So in this case, you have got, let's say, O to P, and this is O to Q like that. From P to Q, this one, or from Q to P, whatever direction that you're going to take. So let's take from P to Q. In this way, the arrow is facing what? Q. From P going to Q. That is now representing the displacement vector. It's not taken from the origin. It's not from the origin, this one. That's a displacement vector. All right. Remember from our introduction, those were the ones that we're referring before, vector A, B, C, D, and so on. It's not taken from the origin. So by using the position vectors now, we can see that PQ, this from P to Q, this is the displacement vector given that we want to determine from these position vectors O to P, which is vector OP, O to Q, which is what? Vector OQ. So it follows that if we were to take a certain direction, let's say we are to consider from the origin, all right? We move, let's say we want to determine vector OP or you want to determine vector OQ. It is in your hands. Let's say you are to determine that. I want you to see where the formula for PQ is obtained from. Let's say we want to determine this vector or Q, all right? To determine that vector or Q, it means we can take this direction from O to P, all right? Then from P to Q, like that. This is the route that we are going to take, the route. To obtain what? Vector or Q. So I want you to see something here. To obtain this vector or Q, a position vector that we can be given direct, but we want to find out how can we determine it? By moving from point O to that Q. So we are going to take this direction, O to P, then from P to Q. So that is OP, from O to P, then from P to what? Then from P to Q, like that. So vector OP, when added to PQ, it is going to give us this part OQ. So we want to determine what? The displacement vector PQ, this one. So to find this, what are we going to simply do? We are going to take this OP to the other side of the equation, since this is an equation. So taking this to the other side, we are going to find out that vector PQ can be written as vector OQ minus OP if we take the OP to the other side. So that's minus what? OP. So this becomes the formula now of determining what? The displacement vector from what? Position vectors. OQ is a position vector. OP, again, position vector. They are taken from what? From the origin. They're taken from the origin. So this becomes a formula. So if we are to analyze this formula here, we can see that, all right, we want to analyze this formula. PQ is equal to, it was just supposed to be Q minus P, which is OQ minus OP. So take note, PQ like this. The last part here is the one that you're going to start with. So it was supposed to be Q minus P, but Q is a point, guys. P is a point. We are supposed to write them as what? Position vector. So you just put what? O for the origin. So that's OQ minus OP. So it is simply this one, Q minus P. So meaning to say, if I am given to find vector AB from points, B being a point, all right? B being a point, A again being a point, I can simply determine that because those points can be written as what? Position vectors. Remember, so it is simply B minus A. So that's OB minus OA to represent position vectors. It is supposed to be B minus A. That is the concept. So whenever we are given points, all right, so let's have it as a point here. Let's just take note. Say, so we can we can put this into conclusion to say, given 2 points, all right, given 2 points, A and what? And B. Given 2 points, A and B, the vector, all right, the vector, or let me just write here, AB, vector AB will be equal to B minus A. So that's OB minus what? OA. So take note, from B minus A, you simply put what? O to represent the position vector. So given what? 2 points A and B, it follows that. It follows that vector AB is equal to what? OB minus OA. So from the 2 points, you obtain what? Position vector OA. From point B, you obtain what? The position vector. That is the concept. So those are the ones that you're going to simply use here. OB minus what? OA as vectors. So this is the same concept, PQ, Q minus what? P. So if we are given something like this, MN, all right, to find vector MN, it means what? N minus what? Minus M. So that's a vector, OM, ON minus OM. Position what? Vectors. If we are given any part C, D like this, so it's going to be D minus what? C, D minus C, which is OD, OC. Just like that, you have got your vectors. So that is the concept that you're going to use when you are given points. You turn them into what? Position vectors in order for you to find a displacement vector. So this also can be used to determine or to find the points. You simply make the subject of the formula, right, from whatever that you're given. So that is the condition that you can use to attempt or to answer questions such as these ones, where you are given what? Points. You have the point. So it is the same thing, guys. I want you to see here. It is the same concept as what we had before here. If we are to use this, only that for this part, we were taking it from the diagram by movement, because we consider that translation vector as a movement. But I want us to just consider one part, all right? Let us just prove this part here. Let us just prove. All right, we obtained vector AB. It was 6, 1, all right? Is this 1, 2, 3, 4, 5, 6, then 1, all right? That is exactly, all right. So using this concept now, right? Let me erase here. Using this concept that we just discussed, that we can obtain the displacement vector from a position vector using the formula, let us determine the vector AB from that concept. It is supposed to be vector AB, it is supposed to be vector OB, that is B minus what? A. So that's OB minus what? OA. Is what? Position vectors, meaning to say OB, this OB here is from the point B, from the point B, the coordinates of that point B. So what are the coordinates of the point B? All right, so going up here, this is our point B. That is the X value is what? 7. And the Y value is what? Is 6. The coordinate of the point B, this point B, that is X is 7. And the Y value is what? 6. So that's the point B, 7 what? 6. So as a column vector now, representing the point B from the origin, there is no effect because it's taken from what? From the origin. So it is simply writing that point B as it is, just that it is now written as a what? As a column vector. We are writing in this manner. That is the only part. We have the position vector of what? OB from the point B. So it is the same thing from the point A, which is going to give us this position vector OA. We need the coordinate, the point A, which is A is here. That is the X value is 1, and the Y value corresponding to A was what? 5. So this point A, X is 1, Y is what? 5. So that's 1 versus what? 5. That's a point. So therefore, the position vector now representing A, which is our vector OA, can be written or represented as what? As 1, 5. We are simply taking those coordinates, the point XY, rewriting it in the same manner XY as a column, starting with X followed by what? By Y, like that. So let us use the formula now and see if we are going to obtain the same answer that we obtained by considering the movement of a translation vector. All right, so AB was going to be what? OB, which is the position vector. Here, 7 what? 7, 6. Minus OA, our A is what? 1, 5. So that's it. We are going to obtain the vector AB, the displacement vector. 7 minus 1, remember the concept, corresponding elements. 7 minus 1, that's a 6. 6 minus 5, that's what? A 1. So we can see that we are obtaining the same answer as before. By what? By movement, but this is done by calculation from what? Position vectors. So we can agree that this calculation is the same. So using that calculation, we do not need now to draw a diagram. When you're given something like this, you don't need to represent this is the point A, this is the point B. Then I'm going to move. If I'm asked to find vector AB, then no. We are not going to apply that concept. From these coordinates, we can find what? These vectors, all right? So from the first one, we are given the point A is 7, 8. So that's, we are having what? From that point A, you have got what? Vector OA, which is the position vector from the origin, which is what? 7, 8. As it is, you do not change anything. And from the point B, we have what? The position vector again, which is what? 2, minus 1. So find the vector AB. So they can write in bold like this. We can see this is written in bold, but us we can present with an arrow like that arrow on top of what? The AB. So represent with an arrow to represent that vector AB in bold. Do not just write AB is equal. Okay, right? So guys, be mathematical. So AB is gonna be what? B minus what? Minus A. So that's OB minus OA, just like that. All right, where OB is our point that we wrote here as a column vector now, 2 minus 1 minus OA, which is what? 7, 8. So that's it. 2 minus 7, that is going to be minus 5, minus 1 minus 8, that is what? Minus 9. So guys, do revise your directed numbers. So this is the concept. All right, so that is how you can simply find or determine these. And another one, it was to find the vector. All right, so this is A, then B, it is vector BA. So remember, I told you guys, vector BA, when you have calculated AB like that, because it is just like this, guys. This is A to B. You have A to B. So BA is simply reversing that. So that's a negative of what? Of the vector AB that you calculated before. Simply a negative of what? Of vector AB. Just the concept. you are simply reversing. So this is going to be negative of vector AB. This is our vector AB minus 5 minus 9. So meaning to say negative times negative, that's a positive. Negative times negative, that's what? A positive. So this is our vector BA. So that is how you can simply determine that. Or you can also determine that by calculation. It's not a problem at all, right? Let us obtain this one by what? Calculation from those position vectors. So BA is going to be what? A minus B. So that's A minus B, which is OA minus OB. So let's say if we are going to obtain the same answer, we have the vector OA, which is what? 7, 8 from the point, minus OB, which is 2 minus what? 1. So let us subtract here. 7 minus 2, that is what? A 5. 8 minus minus 1. So that's 8 minus minus 1. A negative, that's a positive. So 8 plus 1 is what? 9. So as we can see, we are obtaining what? The same answer as before. So it is in your hands, all right, the way that you to calculate or determine your answers at the end. All right, let us consider number 2, the points that you're given. Here, OPQ has got these coordinates, all right, respectively. So that is according to what you're given, this is the origin, O followed by what? By P, followed by Q, followed by R and S. So that is what you're given. So express each of the following as a column vector. A vector OQ. So the vector OQ, guys, this one is simply what? The position vector. Like I said, from the origin, there's no effect. You simply take the point Q as it is, write it as it is. So that's 3 what? 3, 8. If you were to maybe have a calculation, because someone might, okay, since we are given the point O, we can have that one as a calculation. You're simply going to say Q minus what? O. So that's OQ minus what? OO. So what does it mean? What does it mean, OQ? This is the same OQ that we have. So you see, guys, it is already given that one. So B or S, the same here, you are already having that from the point S, from the origin, as long as from the origin, just use that point as a what? As a column vector. All right, so that was it. Then the other part, C, vector PQ. So that is vector PQ. If we are to determine our vector PQ, that is Q minus what? P. So Q minus P, which is OQ minus what? OP, just like that. So OQ from the origin, we have that one, 3, 8, all right, minus OP. P as it is from what? From the origin, we just write as it is as a column. So that's 1, 5 from the point P. So that is it. Subtract 3 minus 1, that is a 2. 8 minus 5, that is a 3. So this is our vector what? Our vector PQ. Just like that, all right? Then another one, QR, which is on D. Q R the same, that's R minus what? R minus Q. So that's R minus Q, which is OR or Q. So that's it. So OR is the point R from the origin. So this is our R here as it is 7 what? 7, 10 minus OQ, which is what? 3, 8. So that's it. We subtract this part. 7 minus what? 3. 7 minus 3 corresponding elements. 7 minus 3, that's what? A 4. Then 10 minus 8, which is what? Which is a 2. So that's our vector That's our vector QR at the end. All right, so we can evaluate all these guys. All right, QS from Q to S, same concept, S minus what? S minus Q. So that is it, OS or Q, you're done. So substitute OS from the origin, the point S, which is what? 10, 3. So that's 10, 3 minus OQ. Our OQ is what? The point Q, 3, 8. So that's 3, 8. So it's all about directed numbers. 10 minus what? 3, which is 7. 3 minus 8, which is what? Negative 5. So that's our vector QS. All right, another one is vector RP. So same concept. RP can be determined. That's P minus what? P minus R. P minus R there. So that's OP or R. Okay. So that is it. From O to P, that's the point P, 1, 5 from the origin, minus OR, which is what? 7, what? 7, 10. So that was it. 1 minus 7, that is a negative 6. 5 minus 10, that is a negative 5. So guys, do revise your directed numbers in as much as you can. All right, so I want you to go through typical questions. All right, also on this one, I want you guys to try this question. But in case where we do not understand, let us communicate in the group. All right, so you can check the description of the channel, so you can join the WhatsApp group and so on. But we can see that all these are direct, just like what we had before. You can also have these, all right, these are points direct, guys, is direct. So O to K, that is OK from the origin. You just take the point K as it is. So that is OK as it is, minus 3, minus 1, 3. The same with OM from the origin. You just take that point M as it is, 8 minus what? 8 minus 1. The same with OL from this point L. We have got that vector OL, which is what? 5, 4. So you can find any of these vectors, anyone. KL, we have that, we can find it, all these guys, so I want you to determine that. All right, then we have got questions such as this one, OL plus LM. All right, this is what you have here. I want you to see something. OL, that is O to L, this one, plus L to M, L to M, like this. If you add this O to L, then L to what? To M, like this. If you combine it, are you seeing that it is the same as moving straight from the origin to the point M, straight to the point M, like that? So that's vector OM. So this one simply represents vector OM, which you already have, of which you can also calculate it, because you have the vector LM here and the vector OL, you have them. So you can add the answers that you have on D and what? E. You're going to see that the answer there was going to be the same as what? 8 minus 1. So if you do not have that answer, it means one of those is wrong. So let us prove that, all right? So I want you to prove that. The same thing here on G. OK plus what? K to L. All right, let's trace the root from the diagram and see what is formulated from that. From O to K, like this, you move from O to K. Then you move from K going to what? To L without change, without like lifting to say we are starting from L going there. It's a continuation that we're having. So are we seeing that we formulated O L. This one from O to L direct. From O to K, then K to L. You started with what? With O. You end with L. Same here, your starting point is O, your end point is what? Is L. So that is same as vector what? OL, which you already have. Vector OL is what? 5, 4 from that position vector concept. So that is our 5, 4. So you see, guys, direct like that. Okay, so it is just a matter of understanding what you are given. So just also try to apply it on other questions. Let's see here, what are they asking here? From this one, that's MK plus KL, from M to what? To K, like this. Then K to what? K to L. So are we seeing that in this case, we started with point M, ending with point L. So that's what? That's simply ML. This is what we're having, M to L straight like that. So this here is equal to vector ML. So if you calculated that vector ML before, all right, of which you calculated it here because you have got LM. So if you have got that vector LM, what are you going to do? Vector ML, remember, will be simply what? A negative of vector LM that you calculated here. So I want you to use that. So from the vector LM, simply multiply it by negative. That's your answer here. All right. So you can see that you can simply attempt these questions, guys, by your own. But if you do not understand, let us communicate. All right. Another one, I'm just going to give you a tip here. The last one from what we are given, that's ML plus LO. All right, from M to what? To L. This is what we're given. Then L to O, from L to O, going this direction. What are we formulating? Are we seeing that we started with M, ending with O? From M going to O, that is the vector that we are formulating. That's vector what? MO. So this one, it is simply equal to what? It is simply equal to vector MO. So vector MO from OM, if we have got vector OM, so MO is simply what? The opposite. It is simply a negative of vector OM. Just multiply OM by what? By a negative. So it's going to be -8, negative times negative, +1. That's our vector what? MO here. So that's -8, 1, just like that. So you see, guys, that you can determine these by calculation and also knowing the vector concept, the movement that we had before, that a vector can be taken by movement from one point to another. So let us do revise. Let us do revise as many questions as we can so that we can prepare ourselves for the exams ahead of time.